Good day everyone, I am Ronzel and in this video we will discuss the Module 12 about calculating the small sample confidence interval estimate for mean when standard deviation is unknown. To start with, we will recall the process of estimation. When we're out of this entire population represented by the circle, we will take a representative to stand for this sample, on where we take the statistic. We will compute for the mean, the standard deviation, and other statistics. Out of these results, we will estimate the population parameters. For our first part, we will mention the difference of point estimate, which is always sample mean because it is a specific numeric value that will best estimate the population mean. On the other hand, the interval estimate demand at the range of values that will use a population mean and the concept of confidence interval. And in this video, we will talk the situation is not giving sigma or the population mean. And by that, we will not use the z-table. Instead, we will use the critical values for students' t-distribution table. The t-distribution table is quite similar to the z-table. The only difference in terms of their curve must scatter the value of the t-distribution, and so it is more bigger. So then let's move on to our formula and the examples.
Hello, I'm Isaiah, and I will show you the formula for our interval estimate. This will read as the interval equals to the sample mean minus the critical value times the standard deviation over the square root of the sample size, and mean plus the critical value multiplied by the standard deviation over the square root of the sample size. In getting the critical value, or t-value for alpha over 2, we will take into consideration of the concept of the degrees of freedom, which is always the sample size, or n-1. So degrees of freedom equals the sample size minus 1. This is how you get the critical value. For the alpha over 2, we'll firstly turn the confidence interval percentage into a decimal. After that, we can have 1 be minus by it over 2. Although, you don't need to do alpha over 2 steps as it already has been provided by the t-distribution table. And after obtaining the df, or degrees of freedom, and the t-value, we will just simply align to know our critical value. So let's move on to our first example. For our first example, we will read measurements are made on a random sample of 23 components drawn from a population size of 100. Assume that the population is normal and the mean measurements of the components in the sample are 67.45 mm with a standard deviation of 2.93 mm. Determine a 95% confidence interval for an estimate of a mean of the population. So, we'll need to list the given first. In our given, we have the sample size of 23, the sample mean of 67.45, and the standard deviation of 2.93. Firstly, we need to find the degrees of freedom, which is subtracting the sample size with 1. So for this problem, we'll have 23 subtracted by 1, which will equal to 22. The next step is to solve for alpha over 2, which is just 1 subtracted by the decimal form of the confidence interval over 2. For this equation, 95% is the confidence interval, so we have to convert it to the decimal form, which is 0.95. So we just have to put it in this form. So 1 minus 0.95 over 2, which equates to 0.05. This will be our alpha over 2. And then, we take out the t-distribution table to find out our t-value. We align our degrees of freedom to 22 and our alpha over 2 of 0.05. And here we find our t-value of 2.074. And so, we have the interval equals to 67.45 minus the critical or t value of 2.074 multiplied by the standard deviation of 2.93 over the square root of 23, and 67.45 plus 2.74 multiplied by the standard deviation of 2.93 then over the square root of 23. Overall, we will get a total of 66.1828 and 68.717. Overall, we will get 66.183 as our lowest confidence interval and 68.717 as our highest confidence interval. Let's move on to another example with the same given, but the confidence interval will be 99%. So again, since they're only the same given, the degrees of freedom n minus 1 will be the same. 23 minus 1 will still be 22. And for the alpha over 2, we'll be converting 99% to a decimal. So 99 to a decimal would make it 0.99. After that, we take 1 and subtract it to 0.99 over 2. And then we get the answer of 0.005. And then we take out the t distribution table to find our t value. Let's align the degrees of freedom of 22 and our alpha over 2 of 0.005. And here we find our t value of 2.819. Rounded off, we will get 65.728 as our lowest confidence interval and 69.172 as our highest confidence interval. And then, let's move on to more examples.
Hello everyone, my name is Ken, and I will be showing you the last few examples. We have here problem 3 and problem 4. So we're gonna start with problem 3, which states the mean of the masses of random samples of 21 blocks is 24 kilograms with a standard deviation of 1.5 or 1.50 kilograms, whatever, the same thing. Determine a 90% confidence interval for estimating the mean mass of the population. So, right off the bat, we have here 4 numbers, which will be our given. So, we have here 21 blocks for our 21 blocks here for our sample size. 20, no, 24 kilograms for our mean. 1.50 kilogram for our standard deviation, and 90% for our confidence interval. So let me write that real quick. Okay, so with these values, we can now solve for our critical value. So critical value is split into 3 parts, which are df, which means degrees of freedom, alpha over 2. I mean, that's it. So to get the df, it's pretty simple actually. Just df is equal to the value of the sample population subtracted by 1. So that would be 21 minus 1, which is 20. So that will become 20 here, and then we're going to head on over to alpha over 2. So for alpha over 2, we divide the value of alpha over 2. So the value of alpha will be 1 minus the value of the confidence interval. We we can't write 90% on the equation itself because 90% isn't a real number. So you're gonna turn that into a real number which will become 0.90. So just divide it by 2 and I'm going to solve it here. So that will become 0.1 over 2 and then that will become 0.05, not 0.0, not point 0, not 0.5 because that would be 0.50, but 0.05. Okay, 0.05. So now we have here our critical value, which is t zeros no t 0.05. Pardon the noise. Uh, written and then t's. It's like written like it's like an integer. So you're gonna want to pull up your t distribution table, and this should be equal to 1.725. We're gonna write here t a2 is equals to 1.725. We finally have all of the values we're gonna need for solving our interval estimate. We're gonna substitute that, so that's gonna become 24 minus 1.725 parenthesis 1.50 over square root of 21. Then write another 24 plus 1.725 1.50. Okay, that doesn't look like a 50 divided by the square root of 21. So this is gonna be a long I'm not gonna solve this on screen because that would be too long, but one thing to keep in mind is that this thing here shouldn't be possible. That's because 21 now square root of 21 isn't a real number, so you're gonna turn that into a real number. Now how? By multiplying this fraction with a fraction of square root of 21 over square root of 21. So to cancel out the square root symbol, so it should look like this, I think. Square root of 21 multiplied by square root of 21 or square root of 21. You're gonna solve that, and then that will become a whole number at the end. It should be. So yeah, we're gonna skip over to our answer. This should be 23.435. We're gonna round down the nearest thousandth place, and then this is gonna be 24.565565. So this will be our answer. So this will be our lowest confidence value. No, this will be our lowest confidence interval, and this will be our highest confidence interval. That's how the problem 3 should go. And for our final example, we have here problem 4, which reads: a random sample of 15 students was selected for a population size of 100 in a certain dormitory. The mean of weekly expenditures of the sample students is 400 pesos, with 17 pesos and 50 centavos for standard deviations. Construct a 95% confidence interval for the average amount of expenditures of the residents in the dormitory. So we have here our 5 numbers, but we will disregard one of them. So we're gonna pay attention to 15 students, which will be our sample size, and then 400 pesos, which will be our mean, 17 pesos and 50 centavos, which will be our standard deviations, and 95%, which will be our confidence interval. Let's start with the value of df, which is the degrees of freedom value of a or alpha over 2. So df, like before, is equal to the population size subtracted by 1. So we substitute, so n becomes 15 and then minus 1, that would be 14. So that's our value for our df. So alpha, just like before, the value of alpha is equal to 1 minus 95%. So turn that into decimal, so that would become 0.95, and then divided by 2. So we're gonna solve that, and that would become 0.05 over 2, and then that would become 0.025. We can now assemble our critical value. Critical value, we're gonna write it like this. Critical value 0.025, and then again written like a square, like an integer, 14, just like that. So again, you're gonna pull up your the distribution table, and this should become 2.145. So now that we have these values, we can now start solving for our interval estimate. Now we're gonna substitute them with the real values. So this will become 400 pesos. 400. I'm just not gonna say pesos because that will be 400 minus 2.145, 5, then 17 pesos and 17 pesos and 50 centavos over the square root of 15, then comma 400 pesos plus 2.145, 17.50. You're gonna turn this into a whole number by multiplying this fraction by the denominator. This time you're gonna multiply 17.50 over 15, multiply it by 15 here, now square root of 15 here, so that on the denominator will become a whole number, because you're practically multiplying the square root of 15 by itself, and that will become, then that will always result in 15. So the our final answers will become 300, now 390.33078, and 400, 409 and 409.692. We're gonna round this off to the hundreds place, because it's, I mean, you don't, it's money, and you don't really see this as centavos. So it's gonna become 390, 390.31 centavo, and 390 pesos and 31 centavo, and 409 and 69 centavo. So that will be our answers. This will become the lowest estimate, and this will become the highest estimate. With dealing with the conclusion, you have to include the confidence interval, because when the confidence interval is different, then definitely our answers will also be different. So this concludes our video, and thank you for watching.